Okay, let's give you guys some more practice. So again, we're on top of a building which happens to be on Saturn. The gravitational pull of Saturn is 8.96 meters per second squared. Now, when I drop a cannonball from here, at 3 seconds a cannonball will be here. 4 seconds it would be here. 5 seconds it would be here. I want to know the distance traveled between 3 and 5 seconds. So I want to know this distance here. Okay, from here to here. Okay, so yeah, so try to draw your acceleration, the speed time graph, acceleration time graph, speed time graph, and distance time graph. Here, just sketch it. Don't you don't need to do it precisely. Just sketch it, and then from these three graphs, find out. Oh, the acceleration will be something like this. Speed will be this. Um, if you want to know the distance traveled, let's say from here to here, you would work out the the area. Well, this here would be 5. You would work out the whole triangle here. But because you want to know between 3 and 5, three is here. You basically want to know this area here. That would represent the distance traveled between 3 and 5. It's just like you doing this. It's just like you finding. Suppose you work out the whole distance from zero. Work out the distance traveled between 0 and 5 seconds. That will give you this whole distance here, and then you would work out the distance traveled. Let's say from here to here, and then you could just get this whole distance here. Take away this bit here. So it's just like you doing this, working out the whole area here from 0 to 5, and then taking away the area between here, between 0 and 3. So that's just like you working out the area of this bit here. So to work out this area, maybe you could cut it in half, like like well, if you want to work out this area here, maybe you can cut it in half. Work out not cut it in half, but cut it here. Work out the area of this rectangle here, and then work out the area of this triangle here. Well, do whatever you want. Somehow find a way to work out the area of this trapezium. Okay. So do whatever you have to do. Press pause and have a go. Okay. So yeah. So sketch the speed, the three graphs. So it will look something like this. Uh, Acceleration time graph. It will be like this. The acceleration is this. So this point is 8.96, and then your speed time graph. Speed time graph. It will be a straight line. Uh, it will be a straight line like this, and this will be y. Well, immediately inside your mind, visualize this: y equals mx plus c, and then the gradient is 8.96 x. Okay, and then your distance time graph, it will be like this. But we don't actually need this. Let's just stick to the speed time graph. Um, so I'm gonna magnify the the speed time graph. Hang on. So let me just draw the speed time graph. So this this is the speed time graph, and the equation for this is y equals 8.96 x. Okay, and we want to know the distance traveled between, let's say, 3 and 5. So so here let's just work this out. What is this point here? Well, the height here is put the 5 into this thing here. That will give you the height. So calculator, clear. Hang on. 8.96. Oh, hang on. 8.996 times 5 equals this. 44.8. So this bit here is 44.8. Okay, and now let's try and work out this bit here. Put the 3 into this thing here. So calculator, clear 8.996 times what? Times 3 equals this. So 26.88. So this point here is 26.88. Was it? Hang on. Yep, 26.88. So there are lots of ways of working out the area. There are lots of ways of working out. Ultimately, you want to know this whole area here. There are lots of ways of doing it. You could split it like this. Work out this this rectangle here, and then you would add it to this area here. Okay. Okay. So let's do that. Well, a good way, I don't know if you know this, but if you get this height plus this height divided by 2, and then you can times the width. Okay, but okay, let's just stick to the rectangle here. Let's work out this rectangle first. Let's do it the long way. Okay, so this area here would be, well, the height here is this, and then we are going to times the width here. The width is 2. Okay, because 3 is here, 5 is here, so the width is 2. So the area of the rectangle is 26.88 times 2. That equals, hang on, calculator, clear, 26.88 times 2 equals this, 5376. 5376. Okay, and what's, oh, and now we need to do this triangle. So the height here is going to be this, take away this. Okay, that would be the height here. So calculator, clear, 44.85. 44.85. Take away 26.88. 26.88 equals that. So the height here is 17.97. 17.97, and then we're going to times it by 2 because that's a width here, and then we're going to divide it by 2 because well, it's half. So when you get the height, you times the width here. That will give you the whole rectangle. But then we only need half of it, so we're going to divide 2. So these two are going to kill off each other. So this bit here is 17.997. Now it's just a matter of getting this, add this. So basically, get this, add this. So this here will be 3 carry the 1, so that will be 7 carry the 1 again. This will be 1 carry the 1, 6, 7. So it will be this. Okay, well, if you get this, add this, it will give you this here. So the distance traveled, so this distance here is our answer here, 71.73, 71.73, and it will be meters. So when you are given this, hang on, let me clear this. If you want to know the distance traveled here, jump to your speed time graph, and basically just work out the area of this thing here. Okay, this is 3, this is 5. Okay, next question here. Now we're on top of a building on Uranus. Gravity's here. Well, after 4.76 seconds, the cannonball will be here. I want to know the acceleration. What is the acceleration at this precise point in time? Okay, so basically, I want to know the acceleration right here. So press. Maybe draw your acceleration time graph, speed time graph, and distance time graph. Okay, and then tell me the acceleration at 4.76 seconds. Okay, so press pause and have a go. Okay, so your hang on, your speed, your acceleration time graph will look like this. The acceleration's here, so it will be 8.69. Your speed time graph will look something like this. So this will be y equals 8.69x, or s equals 8.69t if you like. Your distance time graph will look like this. Okay, so it would be y equals, well, anytime you have a free fall diagram, free falling object, just visualize this gt squared over 2. Okay, so this equation will be this number divided by 2, so that's a gravity divided by 2, and then times so this thing will be the equation for this quadratic here will be 8.69 over 2x squared, if you like. Well, anyway, to answer this question here, what is the acceleration at this time here? So look at your acceleration time graph. Well, when it's 1 second, the acceleration is 8.69. When it's 2, the acceleration is this. When time is 3 seconds, the acceleration is this. 4 seconds is this. Well, who cares if it's in between? 4.76, the acceleration will still be this. So really, this is a trick question. So the acceleration is this meters per second squared. Okay.